Hello friends, in this video we will look at the processing of the bank loan data that is downloaded from the Kaggle website. Kaggle is home for a lot of data sets that can be downloaded for free and the research can be performed on them. This bank loan data set is mainly a bank's data that helps in deciding whether the loan application of a client should be approved or rejected. So it is based on various parameters like what is the income of the person, whether the person owns a home, what is the duration of their job. So similar fields are there in the Kaggle website. So I have downloaded it from the Kaggle and I am linking it with the Python, and we will perform some neural network classification on this data, and we will predict whether a new customer should be allotted the loan or not. So in this we are going to use pandas and numpy, so both of them we have imported. Then we are going to use model selection, train and test split. Basically in Python what we can do is we can divide our training data into testing and training separately, so that we don't show the same data to the model that we have used for training while we want to test our model. So therefore we can split the data into training and testing data. Then we have the scalar class. This is used for converting your data from suppose there is one field which is 1000, the other field is in lakhs, the other field is in 1, 2, 3 only. So what happens is, due to this there is a lot of variation in the data that the classifier has to look at. Therefore we reduce or we bring all the data on a standard scale and then we perform the calculation. Then for neural networks we are importing the MLP classifier, which will help us in classifying the data. And then for accuracy calculation we are using the accuracy score class. So all of these we have to import at the beginning. Later on we will be importing the classes for performing the conversion of categorical data into ordinal data. So let us begin. First of all, we'll read the CSV file using our reading method, that is read CSV, that is available in pandas, and we call this data as the loan data. And as you can see here, we have printed the data here, but however the output is very large and it is difficult to read all the data. So what we can do is we can just make use of loan data.head. It will display the top 5 rows and we can go through all the data, top 5 rows, and we can understand what all is there in the data. Then we can print the shape of the data. So we know that there are 32581 rows and 12 columns are there. Now if you want to find out what are the columns in the data, then we have the loan data.column. So it will print the names of each of the columns. And if you want to get more information like what all fields are there, whether it is a null or a non-null type of data, then how many rows are there for each one which are non-null, so we can find using the info method. And as we can see here, person, age, all the 32581 they are non-null, but as we can see here in this particular employment length, we can see that only 31686 are non-null, remaining are nulls. And this is a float field, this is the object field, this is a float field, integer field. So all this information we can find out using the loan data.info method. Now we want to find out another way of finding the nulls. Are what we can do is, on the pandas we use is null method and we we perform summation on the data. So we know that there are 895 rows in the employment length and 3116 rows in the interest rate that are null values. So what we can do is, while performing the NLP classification on MLP classification on a data, we need to remove the null values. So what we can do is either we can fill the null values with some default value like mean, or we can simply drop the null values. For dropping the null values, we have loan data dot drop any. That means drop all the columns in which data is not there. All the rows should be dropped, and this is a method that is available in the pandas library. And in place is used so that we don't have to copy loan data into another existence. So within the same data frame, the deletion will be performed. Then we print the head of the loan data, and we can print the description of the loan data. So it will print what is the count, how many, then it will print the mean of the data, standard deviation, minimum element, then quartiles 25%, 50%, 75%, then maximum value in a particular field. So like this, different values are printed. So count is going to print how many rows are there after the deletion of the null values. Then we have to deal with the categorical data. So in order to find out what all columns contain the categorical data in which non-numeric values are there, we are using this method. So we will save all those x's in categorical data for in the loan data dot columns if the data type is 0. So 0 data type means it is a object. So no values associated with that particular type of data, and here we can see the list of all the categorical data are listed. Now we have to use the preprocessing class of sklearn and import the label encoder. This label encoder, what it will do is it will convert the categorical data into the nominal or the ordinal data. It will give numeric values to our categorical data. So we will take an instance of the label encoder, and whatever fields were there which had a categorical data, those we will use the fit transform function and convert into non-categorical, no, we will not say non-categorical, but we will convert it to numeric values. And then what we will do is the original columns will be dropped, and the newly formed columns that are there, we will add them to our data. And now when we look at the head of the loan data, we can see here like employee, what were the fields that we have dropped? We have dropped the loan intent. So we can look at the loan intent column. So we can see here now loan intent contains numbers. Earlier it was containing the non-numeric data. So similarly we have converted all the fields. Now we want to separate the dependent variable from the independent. So in this case, whether the loan was allotted or not, that is the dependent variable, and all other fields are the independent variables. So we are copying that into the loan labels field, and we have dropped this loan status from the main data of the loan data, so that we can divide our data into the training and the testing data. So as we can see here, now we are going to scale our data first. First we are going to divide it into training and testing. So for that, train test split function is used, in which the loan data and the loan labels x and y are passed, independent variables and dependent variables are passed. Then what is the test size that we want? We want 40% of the data to be used as the test data, and we have to provide a seed here. If we do not provide this seed, then each time different numbers will get selected. So if we want that same number should get selected again and again, we have to give the seed here. Then we are using the standard scaler, and we are transforming the xtrain and xtest into, we are scaling both the data, and then we are performing the MLP classification or using the ReLU activation method, and again we are giving the random state to it, and then we are performing the scaling, the fit on the xtrain scaled that is created here with this after performing the scaling. Why ytrain is not scaled? Because it is already in the form of zeros and ones, so we don't need to scale it. So then we look at the performance. So we can see here we are getting a warning that it has not converged yet. but then with this data the MLP classifier is not converging. So when we predict using the MLP classifier on the testing data that we have created, and then we compare the original testing by-test with the predictions that the model has made, we get an accuracy of 89%. So this is how we are going to perform the MLP classification using neural nets on bank loan data that is downloaded from Kaggle. It has 12 columns and some of them were categoricals, and we have converted them, we have scaled all the data, and then the MLP classification has been performed. So I hope this video is useful to you and you will yourself download the Kaggle dataset and try to perform all the operations on it. Thank you very much.